Let's see some more questions on the paging topic that we started earlier. So, in the last video, we have seen some of the questions how we can solve paging related problems. Now, let's see some of other examples to solve the paging or to understand the paging in a more detailed way. Okay, so let's see that let's say we have a system, and this system is having a page table. So the system is having a page table, and this page table is having an entry of 4K. Okay, so if there are 4K entries in the page table, then number of pages can be taken from here, that is equal to 2 raised to the power 2 into 2 raised to the power 10, so 2 raised to the power 12. Because page table in page table, the number of entries is equal to number of entries is equal to the number of pages, right? So it is equal to 2 raised to the power 2 into 2 raised to the power 10, so 12. So from here we can say that the p equal to 12 bits. Now la has been given, so this is what we computed from this part. Okay, now this given is the logical address, and this la is 29 bits. Okay, so from here we can calculate the page offset, that is D is equal to 29 minus 12, that is equal to 17 bits. So now we have got the page offset as 17 bits. It is saying that the system has 512 frames. Okay, so 512 frames means f is equal to 9, because 2 to the power 9, so f is equal to 9. Now we have d as 17 and f as 9. From here we can calculate the pa is equal to 17 plus 9. And what will be 17 plus 9? It will be 26. So PA is physical address is 26 bit. So this is what we need to calculate. So from every bit of information you can relate and try to calculate whatever is being asked. Okay, so this is an example of previous type. Similarly, let's say if we have the LAS, and we have the PAS and LAS equal to PAS given as 2 raised to the power 16 bytes, and we have the page size is given as 512 bytes. From here, can we calculate the number of pages and number of frames? So definitely number of pages is equal to 2 raised to the power 16 upon 2 raised to the power 9, and that is equal to 2 raised to the power 7. So number of pages is equal to 128. Okay, similarly number of frames, I believe number of frames will be also equal to number of pages, so it is also equal to 2 raised to the power 7, that is 128. Okay, now so now if here it is 7 bits, right, to represent a frame number. Now it's given that the pt size we need to calculate. Okay, so if we want to calculate the pt size, so definitely for pt it will be number of pages into pte, right? And if we have been given the pte, so pte can be taken as 7, and number of pages is equal to 2 raised to the power 7. So in this way we can calculate the page table size as well from here, right? So I think this is all about paging. Now we will see some good questions on paging. So let's begin with them. So let's say we have a system with logical address given as 40 bits, and we have the page size. Okay, we have the page size as 16 kb, and we have the pte given as 48 bits. It can be converted into byte as well, so we are asked the page table size. Okay, so from here you can say that the pt is equal to 6 byte, right? We'll divide it by 8, so 8 into 6 is 48. So 6 byte is the PTE. Now we need the number of pages. So from here we can calculate the number of pages, and that is equal to the LAS 2 raised to the power 40, right? 2 raised to the power 40 is okay. So from here we can calculate the number of pages. So LA is given as 40 bits. So LA will contain P plus D. And from page size, we can get the page offset, right? So page size is 16 KB. So it is 2 raised to the power 4 into 2 raised to the power 10 byte. So number of pages or page offset could be represented by 14 bits, right? So D is equal to 14. So from here we will get D is equal to 14, and 40 minus 14. So P is equal to 40 minus 14, and that is equal to 6 and 26, right? So it is 26. So number of pages is equal to 2 raised to the power 26. Now PT size will be 2 raised to the power 26 into 6 byte. And let's take it out, 2 raised to the power 20 into 2 raised to the power 6 into 6. So it is 2 raised to the power 6 is 64 times 6 into 2 raised to the power 20. And it is 36, 37, 33, 84 MB. So we can conclude that the page table size is 384 MB, right? So this is how we calculate based upon the given information, right? Now, let's see another question in which we have the page size given, okay? So we have been given the page size, and this page size is equal to 8 KB. Okay, so page size is given, and PA physical address is given as 32 bits, right? And page table size is also given, and it is given as 24 MB. Okay, so page table entry PTE consists of one valid bit plus one dirty bit plus three permission bit plus translation bit. Okay, so along with that, the frame bits. Now we are asked about LA. Okay, so from here for LA we need to have the number of pages, right? And to calculate the number of pages, we need to we can get it from this, but for this we need to have the frame size. So we can calculate this frame F from these two, page size, and because page size is equal to frame size, so number of frames is equal to 2 raised to the power 32 upon 2 raised to the power 3 into 2 raised to the power 10. So this is 2 and 22, and this minus we will do. So 2 raised to the power 19. And we have number of frames 19. So F becomes 19. So this is 19. Now PTE becomes 19 plus 120 plus 4, 24. Sorry, 19 plus 120, 23, 24, and 25 bits. Okay, because page table entry contains one valid bit, one dirty bit, three permission bit, and translation bit. Okay, translation bit is nothing but the F, right? So we have already added F. Note that this F is also known as translation bit. F is the frame number. Okay, so the frame number is also known as translation bit. So it is 24 bits. Okay, so it is translation bit is nothing but the frame number. So 24 bits is equal to 8 byte. So now we have the PTE, okay, and we have the page table size. So we can calculate the number of pages from here. So page table size 24 into 2 to the power 20 upon 2 to the power 3, that is 8 byte. So it gets cancelled to the power 17. So 24 into 2 raised to the power 17. This is the number of pages. So from here we can calculate the total number of pages, page bit, because we need to have this LA, and for this LA we need to calculate P plus D, right? So this we need to calculate. Just a second. So the number of pages is equal to the page table size divide upon PTE. So PTE, I'm sorry, it is 3 bytes, right? Because divide by upon 8 is 3 bytes. So I'm so sorry for this. So number of pages becomes 24 MB upon 3, that is 8 So 8m is can be written as 2 raised to the power 23. Okay. So P is equal to 23 bits, and D we can get it from here, from the page size. So what is the space size? 8 KB. So number of page offset will be 2 raised to the power 3 into 2 raised to the power 10. So D is equal to 13 bits, right? So from here we get the D, that is 13 bits. So LA we can calculate as P plus D, that is 36 bit, right? So 36 bit will be our answer for the LA part. Right, so this is some of the questions. Now we'll see more about the performance of paging in the next video. Okay, till that, keep watching, and do like, share and subscribe, and if you have any doubt, please do post the comment. Okay, thanks.